Example 9.4.2, using the payback rule. The setup for this one says you're evaluating a potential project for your firm. The project requires an upfront investment of $600,000 and is expected to generate cash inflows of $220,000 at the end of each of the next 4 years. The final expected cash flow of $700,000 is expected at the end of year 5 when licensing rights are sold to other firms. You estimate the project's risk-adjusted weighted average cost of capital at 8%. Your firm has a policy of only accepting projects that recover the initial investment within 2 years. What is the payback period for this project, and what does the payback rule say about this project? All right, now with the payback rule, there's no time value money calculation, at least not on this version that we're going to look at. It's just simply looking at the cash flows as they are with no time value money adjustment. The payback rule is just how long it takes to recover your initial investment. So we're not going to discount cash flows or anything like that. We're just going to start with the initial cash outflow and start subtracting cash inflows until we recover the initial investment. And whatever that number turns out to be, that is our payback period. All right, so how do we do this? With this one, we're going to start here. We see our initial outflow. I went ahead and put the timeline in, even though this is not a time value of money calculation, but it still helps to actually see the cash flows mapped out, and it helps to visualize what's happening with the payback period. Because if it doesn't happen to fall on an even year, it helps to visualize where the break actually is. So we're going to start with the initial investment of $600,000, and we're going to look ahead 1 year and see how much comes in. In this case, we've got $220,000 coming in. Well, that is not going to be enough to recover our initial investment. So, we're going to have to look ahead to the second year. So I'm going to go ahead and start keeping track of these. And I'm going to say, I'll say EOY 1 for end of year 1. We started with $600,000 to recover. We had $220,000 come in. And so we have $380,000 left to recover as of the end of year 1, once that 220 comes in. All right, so now what we'll do is once we know what's left to recover at the end of year 1, we'll look ahead to the end of year 2 and see what's coming in at that point and see if that's going to recover the initial investment. And in this case, it's not. We've got $380,000 to recover and $220,000 coming in. So we know we're going to have to look ahead a second year. So we'll go ahead and keep track of that second year. We started the year with $380,000 to recover. At the end of year 2, we have $220,000 coming in. So when we do that subtraction, we'll have, $160,000 left to recover. All right, now we'll do the same thing. This at the end of year 2, right when this $220,000 came in, we now have $160,000 left to recover. And when we look ahead to the next year, we actually have more coming in than we have left to recover. We only need to recover $160,000. We've got $220,000 coming in. So our payback period is going to be somewhere in between year 2, the end of year 2, and the end of year 3. So it's going to be 2-point-something years before we recover our initial investment. So we're going to make a little bit of a simplifying assumption here. To figure out what that point-something is, we're just going to assume that that $220,000 arrives evenly. So same amount comes in every day or every month over the course of the year. And we're just going to do a simple division that is the amount left to recover, $160,000, divided by the amount that's coming in that year to figure out how far through the year we need to go before we actually recover that full $160,000. So what we're really doing is just looking at what portion of $220,000 does $160,000 represent. So we'll type that in and see what we get. I'm going to lop off the last 3 zeros on both of those since those will cancel out anyway. And we are getting 0.7273. All right, so that means we need to go 0.7273 through into year 3 or after the end of year 2 before we fully recover our initial investment. So our payback period is, we knew it was 2 point something years. It turns out it's 2.7273 years. Now, since our firm's investment policy is we only accept projects where we recover the initial investment in 2 years, we would, under our firm's policy, reject this project. And we would not accept it. All right? And that's all the problem asked for. So we are technically done calculating anything for this problem or answering any of the questions. Now, it's worth exploring, though, the payback rule with this particular example, because I think if we just look at the timeline, if we're spending $600,000, we get 4 years worth of income at $220,000 each. All right, so that's what, $880,000 if we were just going to add them up, not adding any compound interest or anything like that. And then we get an additional $700,000 after that. So it's highly unlikely that this is a project that we would want to reject. We're probably going to want to accept it. At least that's what our intuition would say, just looking at the timeline. And yet we're going to reject it based on this payback rule. So what is going on here? Well, it turns out there are some important weaknesses of the payback period. The first one we talked about up front, it's totally ignoring the time value of money, right? We've got cash flows over a 5-year period in this case with an 8% cost of capital. The effect of compound interest is going to be significant there, so we probably shouldn't be ignoring the time value of money. This is the thing that's appealing to our intuition here. The second weakness, it ignores cash flows after the payback period. So it just finds that cutoff point and then it's done. What happens after, in this case, the 2.72 years, doesn't matter. Well, in reality, we've got an extra $700,000 cash inflow at the end of that timeline. So that's a pretty important one to consider. We don't want to just cut that guy off. Right? And finally, there's no rational basis for choosing the cutoff with which to compare the project's payback period. So the firm had a policy of accepting projects that only paid back in 2 years. And in reality, those cutoff rules are just that arbitrary. Someone will decide this is what the cutoff period is, and that's what we look at. So because of these weaknesses, the payback period is definitely not an investment decision rule we want to rely on exclusively. It is pretty useful for getting a rough measure of risk, though. Those projects that recover their initial investment sooner tend to be less risky for the simple fact that we can forecast cash flows and forecast interest rates over a shorter period a little more accurately. We can have a little more confidence in those projections. And the farther out we go, very likely the less confident we are in what we think the interest rate environment will be and what we think those cash flows will be. Of course, that is project dependent and industry dependent, but in general, that's the case. Right, if we look at a net present value profile for this particular project, and I just plugged this into Excel and calculated these, we find that it has a net present value at that 8% discount rate of $605,000. So definitely a valuable project at that rate. And moreover, it has a huge safety margin. Here, the internal rate of return, which is where net present value goes to 0, doesn't happen until all the way out to almost 35%. So it would be really difficult unless we're just really, really uncertain about these cash flows, in which case we should be using a much higher discount rate to adjust for that risk. But unless that's the case, this is a really attractive project that we're foregoing based on the payback period. So I chose that stylized example just to sort of be able to talk about the weaknesses. The difference is not always that stark. As I said, the payback period can give you a rough measure of risk, so it's not a useless measure. It's just not one you want to rely on to make your decision all on its own.